Hello, welcome to another Stride3D video tutorial. In this tutorial, I'm going to be showing you how you can create an external API where you can store your game data. In this case, we are going to be using our game that we created in the last tutorials, and we are going to be storing the player name and the score that he makes every time he plays a game, if there is any score at all. I'm going to show you how this is going to work, so let's run the game. And you can see right away that we are accessing the API and getting a list of high scores. So imagine that this game is a complete success and everyone around the world is playing this game. So we create an external API that is available publicly around the world via the internet, and our copy of the games can connect to that API and retrieve the high scores from everyone around the world. So in this case, we are running our API locally and we are getting our list of high scores here, the scores that I've made. And let's play the game and see how this is going to work. If we get caught without any points, then we get immediately returned back to the start menu, and no score is registered. But if we play and we make some points, let's make 150 points, and now we get prompt to enter our name. So let's enter our name and confirm, and now we see that the score is registered, is available every time we load the start menu again. I'm going to show you with this tutorial how you can use child scenes, and this is a concept that I did not introduce in the last tutorials, and also how you can communicate effectively with an external API. And as a bonus, of course, you will learn how to create a standalone API that you can deploy to Azure, for example. Of course, this API is not production ready, but you get the basic understanding of how you can create an API. I hope you enjoy. Don't forget to subscribe for more videos and to leave a like, and of course leave all the comments that you see fit. Thank you very much, and let's go on. We are going to start by creating our game API. For this, let's open Visual Studio Community. Let's create a new project. Let's find the Web API template. So Web API. And you will see ASP.NET Core Web API. That's the one that we want. So let's click Next. Let's give it a name. Let's call it Game API. Leave the rest as it is. Click Next. The framework, if you have the latest, it should be .NET 8.0, so let's leave it at that. And authentication, we'll leave it at none. And configure for HTTPS can be enabled. And also we want to have the Open API support. We'll have that as a way to test our API endpoints. Let's leave the rest as it is and click Create. And our Web API project is created. Next, we want to prepare our project to start working on it. First thing, we'll want to install some dependencies. So going to the root of our project, clicking on the right mouse button, and we select Manage NuGet Packages. And if we go to Browse, we want to type in Entity Framework. So we want to install Entity Framework Core. So let's click Install and accept all of this. We will also want Entity Framework SQL Server, so let's look for it. And make Microsoft Entity Framework Core SQL Server, that's the one we want. Click Install and apply and accept, and that's installed. Next, we want the Entity Framework Tools, which is this one, and let's install this one as well. Apply and accept. And the entity framework will be responsible for mapping our classes to tables and creating our database. So with that installed, let's go to the next. part, which is creating some folders that we'll need to organize our code. So clicking on the right mouse button, we will add a folder, and we will call this folder the models. This folder will contain the classes or the entities that will map to our database tables. And we are going to also create another folder, and this one will be called data. And this folder will contain a class for configuring the entity framework. And next we'll create a class called score. This class will contain the data from our player's game. So let's do that. Going to our models folder, we're going to add a new class. And we are going to call this class the score class. Next, we are going to add some attributes. Let's create our ID. So this is going to be a GUID, and let's call this ID. Next, we are going to create another attribute that will hold the player's name. So it's already popping up. We'll also have another one that will be the player score. So let's change this here to be player score. And that's it for our class. So keeping in mind that this class will be used to map to a database table. So we'll have a table called scores, and it will contain an ID, a player name of the type string, and a player score with the type int. And let's save this. And that's it for our models. And let's go to our data folder, and let's also create a class. So add class, and we'll call this class the context class. And this class is going to inherit from DB context from the entity framework core. Next, we are going to add some necessary lines of code. So first the constructor. So this is going to be the public context, which is the constructor with the necessary constructor parameters going in. And most important, we are now going to add our public DB set, which is going to map to our score class that we created previously. And this is what is going to be needed to map to the tables of the database. Let's continue from here. There's one thing we forgot to do, which is cleaning up the default examples that come with the Web API project. And this is the weather forecast class that we see here, and also the controller. So let's delete these, and let's also delete the controller for the weather forecast. So delete, and that's it. Next, we are going to further configure our EF core. Going to our program CS class, we are going to add some lines of code. After this line, we are going to need the context class that we created. We are also going to be adding the using statement for entity framework core, and the connection string and we are going to add the connection string name. Just it's going to be default connection. We are going to create a connection string. The connection string will be in the file called appsettings.json. So here on our solution explorer, we're going to open this file, and we are going to add our connection string information here. So we are going to delete this suggestion here, and also delete this. And we are going to get the connection string. Let's save this. To get our connection string, we are going to open this tab here, which is the SQL Server Object Explorer. If you don't see this tab, you can go to View and just click here on SQL Server Object Explorer. And if we click on the server that appears below the SQL server, if we click here, then we will see here on the right side appear on the properties panel some information, and we will see the connection string here. So we are going to select this and copy, and we are going to add this to our default connection here. But we are not done yet, because we are going to need to create a new database, and for that we are going to change the catalog of information here. We'll delete master and we'll create the name of our database, which is not in existence yet, but as soon as we run this code, then it will be created with the name that we leave here. Let's give it a name, and we can call it the game database. And that's it for our connection string. So now that we have everything in place, we can run a command to create our database and our scores table. So let's do that next. Next, in order to create our database with our scores table in the columns, we will need to run a couple of commands. These commands will be ran in the package manage console, which you can find down here. If you can't see it here, then you can search and just type in package, and you should see package manager console, so you can access it from here. Anyways, let's move on. So next we'll need to run the first command. It's going to be called add migration, so you can find it here, and let's call this first migration the initial state. And before we run it, let me explain. So a migration is responsible for getting the information from the code that we just inserted, and with that create an SQL script that we can then run and update our database, update or create our database in this case. So let's call this initial state, and let's run this migration. And let's see what happened here. First of all, it created class here, and this class is a migration, which will create an SQL script to create our scores table, and that will have the columns ID, player name, and player score, just as we defined before. And you will see that we have also a new folder on the Solution Explorer that contains the migration. So now that we have our migration created, we can go back to our package manager console, and now we can update the database. So let's do that. Let's see if we find here the suggestion. So update database and click enter, and we are getting an error here, and this says that invariant culture is supported. Okay, so let's click on our project on the Solution Explorer. Let's click on our game API root folder here, and we can see that invariant globalization is set to true. Let's set this to false and hope that this will fix our problem. Let's save this. Let's Control B to build, and let's try running this command again. And this time we see that something appears here different. So it's looks like some SQL commands, so create database, alter database, and actually we can close this package manager and go to our SQL Server Object Explorer, and let's open our server and let's refresh it. So let's open our databases, and we now see our game database appear here. So let's open this, open the tables, and we see we have a dbo.scores, which is our table. And actually, if we go here and click on view data, and we see that we have our table with an ID, the player name, and the player score. Of course, they don't have anything at this moment, but that's okay. So that's it for our database creation. Next, we will create our controller. The controller contains the endpoints of the API, all the endpoints that will be accessible from the outside that can execute some code, some task, and then return some result. So let's do this the easy way. So let's use the Visual Studio features to create this controller. Going to our controller folder, we are going to add controller. Next, we are going to select the API on the left side here, and we are going to select API controller with actions using entity framework. Let's select this one, click add, and now we are faced with this small window asking us for some things. So the model class, this will be the score model, and the DB context, this will be the context that we created. The database provider is already in the configuration, and the controller name, we will leave it at scores controller. And let's click add, and this can take a little while, so let's wait for it. And there you have it. Let's see what we have here and also what we will need and not need. So we have the API scores. So this gets all the scores. We will need this one. And also we have another one, get score. This gets an individual score by ID. So we won't be using this one. We can delete this one, put score. We will not be using this. This one is a post, and this one is post score. We will be needing this one. Leave this one here. Delete scores, we will not be needing this one. And also this we can delete. So we have our get scores and we have our post score. Let's modify them for our needs. First of all, and this is important because we are going to be using a feature that allow us to test our API. And for that feature, we will need to add the names of the endpoints here. So very easily just give it the same name that is on the method. So this will be get scores and this will be post score. And we are going to get the scores, but we are going to only get the top 10 scores. So let's change this to be get the top 10 scores. And also here we will need to change this. So here we are ordering by the scores and we are going to take 10, which is the top 10, and we are returning as a list. And for the post score, we are going to be deleting this and we are going to be creating something different here. So for the post score endpoint, we'll be needing some kind of object that accepts the information coming from the request to post this score, and this will be the player name and the score. So for this, we'll need to create another class that we will call score DTO, and DTO stands for data transfer object. So this is going to be just an object to transfer this data to our scores table. So let's create that next. So going to our game API, we're going to add another folder that we are going to call the DTO, and inside we are going to create our DTO object, create a class, and we are going to call it score DTO. It's going to be public, that's okay. And this time we are just going to create the player name and the player score. We are going to ignore the ID because the ID is not coming from the request. We are setting the ID ourselves in the API. Let's create this. And also we will need some data annotations to tell our JSON serializer that the player name should map to the JSON player name and the player score to the JSON player score, that sometimes are not serialized with the uppercase first letter. So let's put in these data annotations, and this will be the JSON property name. That's it. And let's put in the name. So this will be player name, and here player score, and this should do it. Save this and go back to our scores controller. And next we are going to change this method, delete the action result being returned, because we are not going to return anything, just an action result. And also here we are going to change this to be the score DTO object, and this here can go. And also we are going to add an annotation that will be, this is going to be here, and let's continue to add our code. We are going to put this into a try catch block to return any error as a bad request. So let's return the bad request here, and let's leave some message. And we can now put our code here. First of all, we are going to create our score object, and then we are going to use that object to insert its data into the table, because we have to have the correct score object. And then we are going to use that score object's data to insert it into the database. So let's do that next. So let's create the score, and let's accept this suggestion. Also, this time we will be creating the ID ourselves. So we do ID, that's correct. And next we are ready to add the score, and this is an asynchronous operation to save the changes. Okay, and we are missing the return statement here. So let's return an OK action result here. If all goes well, we then return an OK 200 data code in our response. We have our endpoints. We have our get scores that give us the top 10 scores, and this would get us an error. So we have to update the name here. So get top 10 scores. So let's look at our endpoints now, and we have our get top 10 scores that returns the top 10, and then we have our post score endpoint that receives some data, which is a score DTO, and maps it to the score object, and then adds it to the database and saves it. And if all goes well, it returns an OK action result, which is a 200 status code. And if there's a problem, then it returns a status code 400 for a bad request. And now we are ready to test our endpoints. And next, we just need to test our API and the controller that we just created. For that, we can use our OpenAPI system that came with our web API, and we only need to run the code. So going up here to the arrow and clicking to run, and it should take a while the first time, but you should see web page appear. And here it is. This is our OpenAPI interface. So if we see here, we have our API scores, get top 10 scores, and the post score as well. If we run the top 10 scores, we won't get anything. So if we try it out, execute, and we see that the response comes out as an empty array here. So let's close this and let's post a score. So let's try this out, and let's give a name for the player. So let's put the name, and let's give it some scores, and let's execute this. And we see we have a 200 code, which is okay. And this means that if it all went well, then the database should hold the first row with the Superman and player score of 150. And let's now run the get top 10 scores. So we should get that entry. Let's execute, and there it is. So we get the player name, and we also get the ID here, but we get the ID, the player name, and the player score. So with this, there is another way to test our API, and let's do that next. Another way that we can test our API is with the program called Postman. So you can go to the internet and search for Postman. And I don't know why this is going to Yahoo, but okay. Anyway, so if you go to postman.com, and you can download this, it's free. So download it for your machine. And with this, we can start the test. So let's do that next. So I already have Postman installed. I'm just going to push it here, and we are going to create new HTTP request. Let's test the get top 10. So for that, we will need the URL. So let's go back to the OpenAPI window that we ran, and we will need this part of the URL. This is the base URL. So let's put it there. And we can also get the endpoint URL. This one is going to be the API scores. So this is going to be a get method, and it's going to be the get top 10 scores, and that's it for this endpoint. So if we click send, and you see that we get the same result that we got from the OpenAI interface. So this is a different way, but it's also useful. And let's now test our post score endpoint. So here we are going to change to be post score. This is going to be a post method now, and we are going to down here select raw and JSON, and also we will need to pass in the JSON data. So for that, we can go back to our OpenAPI interface and opening the endpoint for the post score. We have here a example value. So let's copy this and let's paste it here. Let's change the values. And let's give it some different points. And let's click send to test this, and we get back a 200 OK response. And let's again run the top 10, and we should see that new data in the response. And there it is. We have our Ghost Hunter with 250 points. And that's it for testing our API. We have two methods for testing it, and we should be ready now to update our game to consume these endpoints and our API. So let's do that next. So now that we have our API created, we are ready to update our game, save our score, send it to our API, and also view the top scores. Let's start to do this. First thing we need to do is to open Stride. And I'm going to be using the RPG game, so the Ghost Hunter game from the previous tutorial, but any game would use this same logic to access the APIs. So open the game. Just to recap, so what we want is whenever our player gets caught and the game ends, we want to show a window where we can enter the name and confirm it, and as we confirm it, we will be accessing our post score endpoint and saving our score externally on a database. So let's do that. First thing, we will need to create a new scene. So let's go into our assets and scenes. We'll add a new scene. And let's rename this scene. Let's call it save score. And this scene is going to be a child scene of the level 1 scene. So let's open the level 1 scene. Let's close the start menu for now. And let's drag and drop the save score scene. And it becomes a child of the level 1 scene. So save score. And we are introducing here a concept of child scenes. In this child scene, we are going to have a UI, which is going to be the window for saving and sending the score. Let's go back to our assets folder and let's create the save score UI. So add assets, UI page, and let's rename it. Let's call it save score UI. And very importantly, let's include this to be, sorry, that was too quick, but Let's include this to be in build as a root asset. And also with the scene, we can do the same. So the save score scene, and let's include in build as root asset. And let's go back to our save score UI and let's double click it and start creating our save score UIs. Let's do that next. Let's resize our grids and position this in the center. Let's change the background color. It's going to be this brown color, and let's enter the title. Let's drag in a text block. Select our text block and position it. And let's enter our test. So save your score. Let's make the text bigger and let's align it to center. Next, we are going to add a text input and its label. So let's start with the label. That's going to be a test block as well. And let's change the text to be enter your name. It's going to be centered. And we are going to add the edit test input here below. And let's also rename this input here. So let's select it and let's give it the name of player name. And while we're at it, let's rename the other ones as well. So this could be the title for the window. Just and the other one, let's give it the name of player name label. And what we need next is a button. And this is going to be the confirm button. So when you click it, it will be sending the score with the player name. So let's change the text. Going to the buttons text block and let's just type in confirm and let's change the name of the button to be confirm button. And that's it for our UI for saving the score and the player name and sending it to the API. And the last thing we need to do is to add this to our new scene, our save score scene. So let's do that. Let's save all of this. Let's go back to our level 1 scene and let's add save score UI to our save score scene. So let's drag and drop it. And there it is. And you can see that the UI appears right away. And this is how you will see it in the game. Another important thing to notice is that for the save score scene, we did not need to add a camera because this is going to be rendered inside the level 1 that already contains a camera. Also, if we run our game at the moment, and let's do that, let's run our game. And we click play, and you see that we are in level 1, but we don't see the UI, the save score UI. And that's normal because we need to load it in order to see it. Let's do that next. Next, we are going to be loading our save score window, but want to do that when the player dies in level 1, or when the ghost hunter is caught by a ghost and the game finishes. So let's add that logic. So going to our code, and actually let's open Visual Studio for this. And let's find the script where we want to load our save game window, save score window. So this is going to be the ghost collides with ghost hunter behavior. Click on this one, open it. When we check the collision with ghost and we find that the ghost hunter dies or gets caught by a ghost, here is where we want to run our code to open the save score window before we are going to the start menu. Let's add this logic. And I'm going to paste the code here and explain later. So let's look at the code that we just added. So first of all, we are creating a private field here for the scene, and the scene is our save score scene. At the end here, so when the ghost hunter gets caught by a ghost, we will then execute some logic here. Let's have a look. First thing, if the score is above 0, if there is no scores to save, so it's not useful to send it to the API, and we can right away load the start menu again and start the game again. But if the score is above 0, then the first thing we'll need to do is to remove the hero from the scene, so we do not have collisions anymore. Next, we are loading the save score child scene, and we are using the content load scene, and we are directly loading the save score, and we are giving it a name as well. So we are giving it a name of save score. Next, we are adding the save score scene to the current scene. This is the root scene, which is level 1, and we are adding the save score. And at this point, as the code continues, then we should see the window for the save score appear. And let's test this now. And let's play the game. So if we get caught for a ghost and we didn't make any points, we immediately get sent back to the start menu. But let's see if we make some points. There's 50 points. And now you see our save score window appear. Here we can put name, and we can confirm. So as we run our game and our save score window appears, there is one thing that we want, and that's we want to see the score appear here in the middle. So between the title save your score and the label enter your name, we should see the score, which is 50. We want to see it appear here. For this, we still have to make some changes to the UI page that we've created before. So let's do that. So going back to our Stride Game Studio, you want to edit the save score UI. So, and the asset view, we are going to double click the save score UI, and we are going to get the text block and drag it in here. So in grid, and we select the text block, and we want to resize it where we want our points to appear. Also, don't forget to rename this. So let's rename this to score. And let's make the test align to center. Also, maybe make it a little bigger and of a different color. And Let's align it to center. And while we're here, also we want this to align to center here. So the text alignment to center as well. And we now have our score box and we can reference this. So let's save this. And next, we want to create a startup script to update the score inside the UI. So let's do that next. So going to code, we are going to create a folder that we are going to call save score. And this is going to have to contain the scripts referent to the save score scene, child scene. And inside here, we will create a startup script and we can give it a name of show score. And we'll go back to Visual Studio to edit this. Save this and let's go back to Visual Studio and we can close this window. And we now can see that we have our save score folder here and also the show score. Let's click on the show score startup script and start entering our code here. First thing, we are getting the reference for the UI page, which is the save score UI. Then we are getting the reference for the score text block that we've just created. And then we are updating it with the points that we have at the time that the player loses or gets caught by a ghost or a ghost hunter. Let's save this. So going back to the Stride Game Studio, and we're going to level 1, click on the save score UI in the save score child scene, and on the property grid we are going to add the component script, and it's going to be the show score script. Let's save this and let's go back to Visual Studio and run our code. Now we have the points appearing, and also we made some changes so that the text appears on the center on the input. Next, what we need to do is add the script to manage when we click confirm. And when we do this, then we'll be communicating with our API and we will be sending the points and the name that we entered here. So let's do that next. Next, we want to create a couple of folders to better organize our project. First folder we will create will be the services folder. So let's add folder and let's call it services. And this folder will contain the service to a class that will represent a service to communicate with the API. And while we are at it, let's add also the score manager here. So just drag it in the service pages and you will get asked to move the files to a new location. Okay. And also you want to adjust the namespaces for the move files. Let's click yes. And we're also creating a folder called the DTO folder, which is the same that we have in our API. So add another folder, new folder, and let's call this the DTO folder. And let's right away add the same score DTO that we added in the API. We will add it here as well. So add a class, and we will call this score DTO. And let's make this class public. And let's add the same properties. So this property will be the player name, and this will be the player score. And that's it for this class. Just clean this up and save. And next we are going to our service pages, and we are going to add a new class that we are going to call the API service. We'll also make this class public. And I'm going to add the code now. So let's go over this code now. We have some private fields here, one of which is the HTTP client that will receive an HTTP client object in the constructor. And also there's one that relates to the API base URL. So this is going to be initialized with this base URL. And just to make sure, let's confirm that the port is correct. So going back to our game API project and running our game API. We just need to check if the URL is correct. So the base URL, which is this part here, so 7165, and if we go back to our RPG game 7165, that's okay. And also we can leave our API running because we will need to make requests from our game, so the API always needs to be running. Let's go to the next code. Here we have a couple of methods. These methods will allow us to communicate with the API, and the first one we have is the submit score. So this one takes in a player name and the score that is compatible with our score DTO object that we are creating here as the payload, and this will take the player name and the score, and we then are serializing this to a JSON object, so we then can make a request to our API containing our serialized player name and score, and if the response is successful, it should be returned. Next we have the get top 10 scores method, and this makes a request to get the top 10 scores, and if the response is successful, then it should return a list containing all the score DTO objects, and of course this is deserialized from JSON to a list of score DTOs object, and if the response is a bad response, then it's return null. Let's save this, and we are ready to add our scripts for the confirm in the save score window, and also another script that we will create to see the top 10 scores. Next we are going to go back to our game Stride editor, and we are going to our code folder, and in the save score we are going to add another script, and this time it's going to be an async script because we are making requests to an API. The code might not return right away, so we need to make this an async script. So this is going to be the confirm button click, and we are going to go back to Visual Studio. So let's save this, and we are going to open the save score folder, and we are going to open the confirm button click, and let's clean up this. We will be deleting this code here, and now I'm going to be adding the code and explaining at the end. So let's go over this code that we've just entered. First of all, we need a private field for the UI page. This is going to be the save score UI. And next we are entering some code here in the public execute method. So first we need to get the page, so get the reference for the save score UI. Next we are getting the reference for the confirm button, and we are attaching a click event to this button. So when the button is clicked, we will again get the updated UI page and get the player name reference, which contains the name that the player entered when he ends the game. And next we are instancing the API service, or creating an API service object here that we will use to make our requests to the API. We are encapsulating the API service request inside the try catch block in case that it goes about an error. And so we are submitting the score. So we are accessing the submit score async method that we created in the API service, and we are passing in the player name and the score from the score manager. And at the end, we have to unload the save scores child scene, and for this we are finding the child scene, which is the save score, and if it exists, then we are unloading it, and it should always exist at this point. Next, we are removing the save score from the current scene, and we are resetting the current scene, and we are loading the start menu. And next, we must not forget to add this script to the save score UI page. Let's do that. Let's go back to our Stride Game Studio and let's select the save score UI, add a component, script, and the confirm button click script. Let's make sure it's added. It's added there. And now let's test the game. And before we run our game, let's go back to our game API project, and while the API is running, let's go into the controllers folder, open the score controllers, and let's go to the post score, and let's put a breakpoint just here at the beginning of our post score endpoint method. Let's go back to our game and let's run it. Let's play the game, make some points. Let's enter our player name and let's confirm. And we see that in our API project, the endpoint was it. So let's step through this. So if we go here to our object, we are receiving the player name, player one, and we are receiving the score. And also we are mapping this to a new score object. So let's continue. And we've created the score object. It contains the ID, the player one and 100, so it's ready to be entered into the database. So let's continue. Let's save the changes, and it returns okay. And as we go through, we are back here. So the game returned to the start menu, but we have not implemented the iScores list here to be shown here. So let's close this and let's just confirm that that the player name and score was entered correctly. So let's go to our OpenAPI interface, which is here, and let's get the top 10 scores. Let's try it out, execute, and we can see here that the player 1 and 100 score is entered correctly. So we now have 3 entries for our scores database. So this concludes the confirm button click script, and let's move on to show the iScores in the start menu. In order to show our iScores in the start menu, we are going to have to create another UI page. So let's go back to the start menu scene. Let's go to assets, scenes, and let's click twice on start menu. And we are going to, on the side here, we are going to add the iScores list. And every time that the start menu scene is loaded, we will see the iScores get updated. So let's do that. We're going to assets. We are going to add another UI page. And we are going to call it iScores UI. And don't forget to include in build as root asset. And let's click twice on this, click on grid, and let's put it on the side somewhere here, so about here. And let's add a test block. Let's select the test block and resize it. And we can change the font size to 25, give it a different color, maybe yellow. Let's copy the color because we will need to put it on the iScores list. And let's give it the test of iScores. Let's center this. And now let's add another text block. We can rename also this to iScores or just call it title. And let's rename this to iScores list. And let's resize it. Let's paste in the color that we had before. The size we can keep it at 20, and let's align it to center. And that's it for our iScores UI page. Next, we go back to the start menu and we will add the iScores UI to the start menu scene. And right away we see it appear here on the right side. So next, what we will need to do is to add script, async script, and to get the iScores and to show them here. So let's do that next. So going to our code folder, we are going to our start menu code folder, and we are going to create a new script, and it's going to be an async script, and we want to give it a name, so show iScores. And let's go back to Visual Studio to edit this. So going back to our Visual Studio, and let's go to the start menu and click on show iScores. We'll delete this code here because we'll not be needing it, and I'm going to add the code and explain at the end as usual. So let's go over this code. So first we are creating an instance of the API service so we can connect with the API. So next we are getting the page, the UI page reference, and we are also getting the reference for the iScores list text block that we've created before, and we are calling the API to get the top 10 scores. Next we will display the iScores. For that, we are using the string builder class to add append each line. So for each score inside the list of score details that we've received, we are going to add a line containing the player name and the dash and then the player score. And at the end, we will add this string to our iScores text block. If any error occurs, then this is set up to fail silently, so the information will not be displayed, but the game will continue to work. So let's save this. And let's go back to our Stride game editor, and let's add this script to our iScores UI. So clicking on our iScores UI, we are going to add a component, scripts, and we are going to add the show iScores script. Let's build this, and let's go back to Visual Studio and run the game. And we see that we have our iScores, but the scores in the player name are not appearing because there was an error. So what's causing this error? Let's have a look. One possible cause is the JSON not being correctly mapped to the DTO object, score object. So let's have a look. Okay, so we need to define, as we did on the API, we need to define a data annotation with the JSON property name. JSON. And let's save this and run the game and see if everything works fine this time. And this time we get the iScores that we have. The Ghost Hunter having been in first because it has more points and so on. So let's play a couple more games to see if it gets updated. And there you have it. And this concludes this tutorial where you learn how to set up an API and have our game communicating with it. And also you learned about child scenes and you learn a little bit more about how to use the Stride Game Studio and edit your game further. So I hope you enjoyed this tutorial, and always leave your comments and leave your suggestions. I'm going to try to make more videos. And that's it. I hope you have enjoyed. Hope to see you next time.